Well, hello. Today we are starting Unit 2. Unit 2 is about bivariate data. And so if you recall Unit 1 being about univariate data, which is where we had one variable, clearly this unit is about having two variables. One of the things that we are going to be focused on quite a lot during this unit is a graph called a scatter plot. Right here is a picture of a scatter plot, and on this scatter plot there is something called a line of best fit, which is that red line. So when you look at a scatter plot, if there is sort of a trend to that data, you can represent that trend with a line that goes through the majority of that data as best as possible, as closely as possible. That's called the line of best fit. The official name is the ordinary least squares line, which I thought I would just tell you in case you would like to know that. I like knowing things like that. We also will be talking about a measure of a data set that is called correlation. And so correlation is a measure of the strength and direction of that linear relationship that you might find. Now, in order for this data to make a scatter plot, you need to have things that plot as dots, right? A scatter plot is made of all these individual points. And so a point on a graph like this consists of two numbers, right? You have an ordered pair. Okay, so you have an ordered pair such as 4, 5, right? And that means you go 4 units to the right and up 5, and you put a dot in that location. So in order to have a scatter plot, you have to have points, and each point consists of two numbers, which means you need to have bivariate data, because you need to have two variables, two measures, and those measures need to be numerical data. So two numbers are needed in order to make a point, and you need to have a lot of points like that, and then that's called a scatter plot. So I'd like to do this movie activity, and when I do this live in a classroom, I just have people partner up. So that's going to prove a little bit tricky right now because you might be watching this video by yourself. So I'm going to ask at a point in a little bit that you find someone in your house to help you get the rest of this data, or maybe that you text a picture of what you're doing to a friend of yours who would be your partner, something along those lines. Of course, if you are really stuck, you can just make up the other half of the data, but that is not nearly as fun. Okay, so to do this activity, I'd like you to make a list of 10 movies that you have seen. Now, it is actually easier to do this activity if you do not just list like your I'm not asking you to like list the top 10 movies, your favorite 10 movies. That actually is going to make this activity harder. So it's better to just think of 10 movies you've seen. Maybe there was something that your dad made you watch, like Caddyshack, and you didn't really like it. That's okay. You can put it on the list anyway. Or maybe you watched something for a different class, like for your English class or your film class. And you can include that, right? Even if you didn't like it. You can include movies from your childhood, right? Maybe you watched Toy Story over and over again when you were a little person, right? And so you could include that. Maybe you babysat your cousins recently, had to watch something with them. So you can list any movies you've seen, no judgment. Then, after you list those 10 movies, you're going to give them points. This part is going to seem backwards to some of you, okay? But I want you to really look at these directions, okay? Your least favorite is going to get the least points, 1. And your most favorite movie on this list is going to get the most points, 10, like being a perfect 10. So the more you like it, the more points you give it. You cannot repeat numbers. So you're going to have one movie that is the perfect 10, then the 9, then the 8, then the 7, down to your least favorite, which is a 1, okay? And so nothing can be tied. You have 10 different numbers for your 10 different movies, okay? And then after that, you will trade lists with your partner, if you could, right? If you can, like if you're watching this on, and you know your friend who's in class is watching this, you guys could do this via text right now, or you can just ask someone in your house to also rate your movies, okay? So list your movies, rank them, rate them, I should say. 10 is the best, 1 is the worst. And then give your paper to someone else they will look at your movies and they will do the same assignment of numbers. 10 is the best, 1 is the worst. Okay, and so it should come back to you as a list of movies, and each movie has 2 numbers. Okay, go ahead and pause, get that done. Okay, at this point you should have your list of 10 movies, and you should have your numbers for each, and you should have someone else's numbers for your movies. Okay, so let's say that I rated a movie 1. I did not like it. And the person who rated my movies as well rated it a 2. Right, so I have my data, and here's the name of a movie, and then 1 and 2. So I would plot that on my grid here as over 1 up 2. That would be this data point. 4, 5 is about there. 6, 8 is here. I brushed my pen against that by accident. Right, so you just plot your dots, however they may be. And I'd like to point out to you that the graph that you're making is called a scatter plot. A scatter plot shows the relationship between 2 quantitative variables. So we pointed that out in the introduction, that you need to have for each dot on a scatter plot, you would need to have an ordered pair, something comma something. So you need to have 2, and they have to be numbers. Now the look of the graph is interesting, right? So like my graph so far looks like the dots are going uphill to the right. That's interesting. But we also are going to look at a numerical value that's going to describe this relationship, because I'm interested in, like, should I try to go to a movie with this partner of mine? Are we even going to like the same things? Or am I going to be stuck watching something that is not good and my, buddy here likes it, but I think it's a horrible movie? Right? So something that I could use to measure that is what's called correlation. Now, this is the textbook definition of correlation. And oftentimes when I ask this as a test question, I get like half of this description. So make sure that you know that correlation tells me 2 things. It tells me both the strength and the direction of the linear relationship between the data. So when I say strength, I'm referring to positive versus negative, okay? And when I'm talking, oh no, that's not right. I just said that backwards. I'm sorry. Okay, when I'm talking about direction, okay, when I'm talking about direction, I am talking about positive versus negative. And when I'm talking about strength, clearly strength is being strong, or it could be the opposite of that, being weak, okay? So if you look at these little pictures that I have over here, positive is when your graph, like the points in your graph, generally are tilting upward. So this is an example of that. This is also an example of that. It isn't tilting as upward, right? Because the dots are like more spread out. It's a little harder to discern. But overall, like as you move to the right for 1, I think this is the way to think about it. As I get bigger values on this x-axis, the y-axis values are getting bigger as well, right? So this point has a large x and a large y. This point has a small x and a small y, right? So if that's kind of generally true of your points, big goes with big and small goes with small, that's a positive relationship. Whereas a negative relationship is the opposite of that. This point, for example, has a large x but a small y. This point has a small x but a large y. In other words, my line is trending down to the right. Okay, same thing here, down to the right. And then strong versus weak, we want to kind of think about that separately. Both of these are strong because the points are lying very tightly to a line of best fit kind of shape, whereas these are more spread out, and you can see words like moderate and weak, right? You can just kind of use those descriptively. Look at the graph, see what you think. And then none is like when your points look like you just dropped marbles on the floor and they just rolled around. Okay, that's no correlation whatsoever. Now, correlation actually is a number. We are going to talk about how to calculate it. And the number that you get for correlation has to be between -1 and 1. So if you have a perfect 1 for correlation, that means that you have this kind of graph, only more so, like the dots are exactly on a line, perfectly, dot, 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 right down the line, okay? Whereas if you have a perfect -1 correlation, you have a line that tilts downward, but again, the points would be perfectly on the line, like exactly on a line. And then it's a matter of degree from there. So if you have no correlation whatsoever, that's 0. That's the marbles on the floor kind of picture, okay? And then the pictures that I actually have here probably are more like in this zone or this zone, right? Those are my strong pictures up here, just like a little bit less than 1 or a little bit more than -1. And then your moderate or your weak, those are things that are more like in here, like 5, 0.6, something like that. All right. So that's the span that correlation can take. Do you see the test question I could ask? I ask a question like, true or false, correlation can be 2.5. I certainly could ask that. What is the answer? False, right? Because correlation has to be between -1 and 1. Okay, so now let's go back and find out if your movie partner is someone you want to actually see movies with, okay? So the variable that is used for correlation is the letter R, correlation, these R's, okay? And we're going to find them on our calculator. Okay, so here I am on my calculator. And where you're going to go to put in your data is just like always, go into statistics, go into edit. And I have pre-entered, these were the ratings of my movies by me. These are the ratings of my movies by my friend. Okay, and then we're going to learn a new sequence of steps. So statistics, then over to calculate, and it's item number 4. Now there actually are 2 of these. There's this linear regression, and then number 8 on my list is also a linear regression. Just to be consistent, I am always going to be using item number 4. I picked this one because it looks more like what you learned in algebra. Y equals mx plus b is something you learned in algebra. So if you just think that the a is like m, that's your slope, and b is your y-intercept. Okay, so it's more similar to what you've seen in the past. Okay, now if my data were not in list 1 and list 2, I would edit that, but that is where my data is. So I'm just going to come down here, and then you see on the notes, I did say that we're going to type a Y1 right here. And that's not so much for what we're doing today in class, but just for the future. So I want to have Y1. That's in the variables menu. Over to Y variables. I'm going to hit enter on Y variables and function. And I'm going to hit enter and get that Y1 symbol. Okay. What that is going to do is it's going to put the line of best fit equation in my y equals part of my calculator for me. Then I'm going to push calculate. Okay, and now I see all of this. Now some of you right now are panicking because you do not see the R. Okay, you might just have like the first 3 lines of writing. If that is you, we need to change your calculator settings. We only need to do this the one time. So if no one else messes with your calculator, you'll be good to go from now on. But if someone messes with it, this is how you fix it. So in the thing that says catalog, I pushed second and the 0. You're going to go along here until you get to the D's. So D, and there's something called diagnostic on. I do not think this is located anywhere else in the calculator. I think it's only on this list. So diagnostic on, which is now at the bottom of my screen, I'm going to pick that, and I'm going to hit enter. Now that's very much like nothing, right? It's just a big nothing ball because it seems like nothing happened. But now, if you did not have everything show up previously, it will show up this time. Okay, so now this time when we go in and run, this is what's called a linear regression. When we run our linear regression, the R value will show up. Okay, so R is a measure of correlation. It's between -1 and 1. This correlation is like 0.8. So I think the person I did this data with, who rated my movies, that person and I would probably get along pretty well in terms of going to the movies. We like pretty much the same things. Okay? So, oh, actually, that was supposed to be a space for guessing what our correlation was going to be. We didn't actually do that. Okay, so like 0.8 is what I got for my correlation. So you can go back here. 0.63-ish was about what I got for R squared. And my line of best fit, this is the slope. So 0.794, I'm going to say, rounded, times x plus 1.13. Okay, we usually write a little hat on top of this y because it's the predicted y. So this is my line of best fit equation, right? So the a is going to be my slope. The b is going to be my y-intercept. And that is my line of best fit equation. We'll be talking about that more in coming days. What I really wanted to talk about today was correlation. So the fact that my 0.8 is around here, looks like my husband and I can still stay married because we like a lot of the same movies and we dislike a lot of the same movies. That's good. My R squared is a measure of how much of the variability in the dependent variable can be attributed to the independent variable. So how much of the change in my husband's ratings is because of my ratings? This doesn't really make sense in this context, but we will have some contexts in which an R squared value is important. So for now, we can just make a note. It is a measure of how much variation in y is due to x. You can roughly think of it as a percent, okay? And so I had a little note here that we use catalog and diagnostic on if your R value doesn't show, and we went over that. Okay, so let's see if we've done everything we need to do. On the calculator, how can we see the scatter plot with the line of best fit? Oh, that's a great question. Let's do that. Okay, so if I go into stat plot like I have before for the box and whisker plot or for the histogram, I now can select this box. This is the scatter plot. Notice that 2 lists show up here. Whereas when I did the histogram before, that was a 1 variable graph, right? So only 1 list showed up. So this is a bivariate graph. So I could turn that on. I'm going to do zoom statistics just like I have in the past. And look at that. That is just awesome. Those are my scatter plot points. And because of typing in that y1, there is my line of best fit equation with all those decimal places represented. On my paper, I rounded it off to just 0.8, but look at all of that. Woo! Now, if I wanted to transfer this to a piece of paper, I could trace, and you can see that every ordered pair in my plot, at the top right now it says plot 1. So as I trace through, it's just telling me the ordered pairs that were on my scattered plot. But if I arrow up, notice I'm in red now. This is now saying I'm on Y1. So I can move along the line of best fit and find an ordered pair that I am able to put on my piece of paper pretty easily. So let's look for a nice, kind of a decent pair of numbers that aren't too decimally. Yeah, maybe this pair. 4.6 and about 4.8. Depending on how my graph paper looked, that might be an easy point to plot. So I could just find a couple ordered pairs that are on my line and transfer them to my piece of paper if I needed to draw a scatter plot. 6.8, 6.5, right? Plot a couple points and then draw with a straight edge or a ruler this line. And then I can also plot these scatter plot points, and then I'd have this exact paper or exact picture on my paper. Okay? So those are some important things. I can also look at table. If you look in table, oops, my table isn't set up very well. Let me change that. I want it to automatically fill in. Okay, so back here in table, now it's telling me all sorts of different ordered pairs that are on my line of best fit. So that would be another place that I could go if I wanted to find some ordered pairs in order to come up with this graph on a piece of paper. So we talked about doing stat plot, we talked about that, we talked about tracing. Woo, good job us. Okay, the last little bit of notes today, just some facts, things that people kind of forget or don't realize. So one thing, R is between -1 and 1. It describes strength and direction of the linear relationship. If the points lie close to a downward sloping line, R is close to -1. If the points lie close to an upward sloping line, your correlation is close to +1. And a correlation that is close to 0 means you have a weak correlation. It looks like those marbles on the floor just kind of scattered about. Now, this is huge. People mess this up all the time. R does not tell us about cause and effect, or which variable might be explanatory and which one might be response. That's just a fancier way of saying the same thing. We do not even know if there's a cause and effect relationship. You might have two things that are related to each other, but one is not driving the other. They just coexist, right? Now, I didn't show you how we calculate R, but the formula that is behind what your calculator is doing to figure out correlation actually utilizes the mean or the average. It actually utilizes kind of an idea sort of like standard deviation. It has a square root in it. So because the creation of correlation uses the mean, that means correlation is not resistant to outliers. If there are outliers in your data, that could have a huge impact on your correlation value. So we need to bear that in mind. Statisticians who report R usually will also say what is the average X, what is the average Y, and what are the standard deviations for both the X and the Y variable, because those things are utilized, those ideas are utilized in the calculation of correlation. So those kind of come as a package together if you are being very good as a statistician. You are now all set to do problem set 2.1. If any of this was confusing, remember that you have the power to rewind and watch those calculator steps again, for example, and definitely ask your teacher if you're confused, okay? Good luck with your problem set.